Hello, everybody. Welcome to another episode of the Critical Science Podcast. I had to think about that for a second. I was about to call out the name of my blog. So today I want to talk about this story. I just saw it in CNN. All right. This was posted yesterday afternoon, so Thursday, May 23rd. Today's the 24th. And I have it over here on the other screen. It's titled, Toxic Chemical Exposure During Pregnancy Linked to Serious Health Issues by Elementary School. Holy crap. That's scary. So what they're talking about is, they're talking about a study is done in Europe, is actually published in JAMA Network Open, which is a freely available journal. They do open access publishing and all that stuff. So the authors pay some money to the journal, and then the journal allows anybody to read the paper. You don't have to have a subscription to the journal. And the paper is titled Prenatal Exposure to Chemical Mixtures and Metabolic Syndrome Risk in Children. And I'll have a link to this paper in the show notes. Now, what I wanted to do today was I wanted to demonstrate for you how we can use those 7 tips that we talked about in the last episode. How to use those 7 tips to assess a study. And here we've got a study that we're going to assess. Now, I can tell you right now, when I saw this, I just kind of laughed because, another one of these studies. Sweet. Okay, so let's go through this. What the CNN article is saying is, and I'll read it right here. Children born to European mothers exposed to 4 families of chemicals that disrupt the body's endocrine or hormone system. So how to describe hormones. In our bodies, we have these chemicals that can influence how different things work. Most hormones that we are familiar with are like estrogen and testosterone, right? And so they help us with reproduction. They help us with secondary sex characteristics, things like that. And then, there's other hormones as well. Like I said, those are the 2 that we usually talk a lot about. There's other ones too. Insulin is technically a hormone. Insulin is, chemical in your body that helps your muscles absorb glucose or sugar from your blood so that your muscles can do all kinds of great things. So if you get into a fight or flight response, what ends up happening is your insulin is going to kick up so that your muscles can actually have the sugars or the foods necessary for them to move and fight or run. So that's kind of what hormones do. And there's tons of different hormones. Okay. So anytime we talk about endocrine, we're talking about hormones. But like I said, usually we normally only think about estrogen and testosterone, but there's tons and tons and tons of other ones. All right. So let's get back to this. So what's happening here is there's a study, and they're looking, these were moms in Europe giving birth to kids. They're exposed, the article says, to 4 families of chemicals. They were exposed to a lot more chemicals than that, right? Because we're always exposed to lots and lots of chemicals. And these are chemicals, the authors of the paper chose these because they feel that these are chemicals that are going to disrupt the endocrine system or disrupt our hormones. And they were trying to associate these changes or these elevations of these different chemicals. They're trying to associate it with metabolic syndrome in children at ages 6 and 11. Now, okay, before we go on, the first thing that I did was I thought about this for this. Okay, come on. I've taken so much physiology. I specialize in endocrine, by the way. That was in my PhD and my bachelor's work. A lot of my focus was on endocrine. So I know the endocrine systems, plural, extremely well. And I'm thinking, metabolic syndrome, I don't remember this being something that gets diagnosed in children. But I'm not the expert on metabolic syndrome in children. I'm an expert in metabolic syndrome in general, in adults. What's this with children? So I went to the expert, the American Academy of Pediatrics. Now, people who listen to this podcast will know I don't always agree with them. In fact, I don't agree with them a lot about certain things because they just get the science wrong. But here, this is something where we can trust the American Academy of Pediatrics because it is clinical. We are talking not about, not about basic science, basic research. So this is them saying, can we diagnose metabolic syndrome in children and adolescents? Yes or no? So this is from 2017. It's called the Metabolic Syndrome in Children and Adolescents, Shifting the Focus to Cardiometabolic Risk Factor Clustering. And I wasn't surprised. I read the whole thing, and I wasn't surprised to learn, yeah, metabolic syndrome isn't really a child and adolescent issue, because metabolic syndrome is actually something that is associated with cardiovascular disease, and it really came into its own in the late 80s, early 90s, and it's with adults. So we don't actually see what we would typically call metabolic syndrome in children or adolescents. Now, they might have risk factors that will then, when they're adults, put them at risk for metabolic syndrome, right? And so this is where, DOD, I used to work at the Army. One of the things that the generals were very, very concerned about was the fact that, a lot of our children today, most of them at the age of 17 cannot qualify for the armed services. They can't, because they don't have the right physical fitness that is required for warfighters, I should say, because I'm talking DOD, for warfighters in the Department of Defense. They don't meet those criteria, and because they don't meet those criteria, it's a bit of a problem. And so, this is a big deal, right? The fact, and people are still trying to figure out, what's going on? Why is this happening? Some people have the hypothesis, which my guess is that the people who wrote this paper in JAMA Network, my guess is that their hypothesis is that it's the chemicals to blame. It's not the screens. It's not the fact that the children don't eat well. It's not the fact that the children aren't as active as they used to be. It's the fact that they have all these chemicals. That's my guess. I don't know. They don't come right out and say what their hypothesis actually is. Kind of seems like that's what it is. But anyway, back to the point. The point is this. The American Academy of Pediatrics says we can't diagnose metabolic syndrome in children because it doesn't exist. So, going back to this paper, they are talking about metabolic syndrome risk in children. So they're talking about the risk of children developing metabolic syndrome in this paper. And we've already just read, right, from the American Academy of Pediatrics, you can't diagnose this. So what exactly are they? What they're actually doing in the paper is they are looking at biomarkers. So things in the body, chemicals in the body that we naturally produce, they're looking at those to see, are any of these that could be associated with metabolic syndrome in adults happening in children, and therefore the children have metabolic syndrome. Now, like I said, metabolic syndrome is actually based on cardiovascular issues. That's what it's focused on. We don't see these cardiovascular issues in children and in adolescents. So therefore, you cannot diagnose these children with metabolic syndrome. And the authors are very careful, because what they do is instead they're saying, we're going to instead define risk for metabolic syndrome based on some mathematical properties of these biomarkers that we can measure. So again, we don't actually know that they're measuring risk for metabolic syndrome. It's what they think they're doing. We have no idea that what they're doing is mathematically sound or anything else. So these are some technical things that, you may not be able to pick up on because you don't have the background, but I'm telling you these things just as additional background to the story. Okay, so let's go back to our 7 tips. The first tip, if you remember, is it doesn't matter who paid for the study. Judge the science on its science, right? So, okay, I'm not judging them based on who paid for it. I have no idea who paid for this. I guess I get the look. I'm pretty sure it was the European Commission paid for it, but I don't know. Could be the individual countries. Who paid for this? Looking. Funding support. Oh my gosh, this is huge. The European Union Horizon 2020 research program is the biggest funder, and then there's individual funders as well for the different countries. And they looked at children or mother-child pairs, as they call them, from across 6 different EU countries, and they're including the UK in there because at the time they were part of the UK. Most of this data, I believe, was collected before Brexit, technically. So there you go. Anyway, back to the tips. Okay, so we did number 1. I don't really care who pays. I didn't even know who paid before I even came on to this, came on to the podcast. I had no idea. Be skeptical. So we need to be skeptical if this is the only study making a claim. Pretty much right now, I think this is the only study making this particular claim. If the study involves a small number of people, how many child-mother pairs were there? Let's see here. If I remember correctly, and I'm just going to double check to make sure, I believe it was 1,000. So we're going to scroll down. My goodness. Yes, 1,301. That's not a lot. Okay. So now we go to, is the study randomized? No, the study is not randomized. This is what's called a cohort study. So in other words, they just got a bunch of people. They probably respond to an ad or something, or maybe their doctor referred them into this program. And what they did was they just measured things in these people. And that's it. So there's no counterfactual. Counterfactual here would be a control group, for instance. There's no control group. This is just a group of people that they happen to be studying. Now, the population matters. If we're trying to make inferences about the U.S., then we need to be looking at U.S. People, not people in Europe. And so what we have here is we've got people from 6 different countries in Europe. Probably not a bad, you could probably make some, pretty weak conclusions about, Europe, but Europe is a pretty large and diverse place. So really, you can't make a lot of really good inferences about any particular one of these countries either, because, we're talking about 1,300 people, or 1,301 divided by 6. So we're talking about 200 plus people per country. So this really isn't very good. You can't draw many inferences about any individual country. You can't really draw inferences about Europe, because I'm here to tell you, these countries here, mostly Western European, you can't draw a lot of things about Eastern European because everything's different. The culture is different, the food's different, all these different things are different. Genetics are different. So the population matters. Okay, so is there uncertainty? The uncertainty is real, it's pernicious. There's definitely some uncertainty. Now, let's go back to that be skeptical thing. I forgot a few things. So in us being skeptical, what we want to do is we want to think about, okay, so how good really is this study? Okay, we talked about the fact that it's a cohort. This is an observational study. There's no randomization. It's not a clinical trial, which means you cannot make causal inferences. So we can't say that this mixture of chemicals caused metabolic syndrome in children. Number 1, because metabolic syndrome doesn't occur in children. But number 2, because of the study design, it's not a causal study. It's an observational study. It's an epidemiological study. We just can't do that. There are confounding variables. And so a confounding variable is something that you need to measure that could be influencing the results of your study. Now, the authors of the study say, we used a Bayesian network, or not a Bayesian network, sorry, a directed acyclic graph to look at all the possible confounders. Now, again, I'm getting very technical here. This isn't something that you may necessarily be skilled in, but if you go into their supplemental information, you go to E-figure 4, there they show their directed acyclic graph. I'm here to tell you they're missing a lot of things. Let me tell you some things they're missing. So if we're talking about children, and we're talking about, one of the primary drivers for metabolic syndrome risk in adulthood when looking at children is really obesity. Now, the only arrows coming in to child metabolic syndrome are the mom's education, the mom's body mass index, and BMI is not a good measure for a lot of things, because you could be, you could have a lot of muscles and be technically obese, not have a lot of fat. Mom's fish intake in pregnancy, no. The prenatal chemical mixtures, that's what they're trying to test. the cohort. So the group, where was this group at? What lab was testing them? Stuff like that. Maternal smoking in pregnancy, maternal age in pregnancy, parental country of birth. So they're looking at all these different things. What aren't they looking at? They're not looking at the activity levels of these children. So that's not in there. They never asked. In fact, they didn't ask anything of the children. All they did was just take blood draws, I think urine samples from the children. That's it. That's all they did. No, I'm pretty sure it's just blood draws. Probably not even urine. But anyway, they just measured the biomarkers in the children. They didn't ask any questions about children. They didn't look at, what is this child's food intake like? How many calories are they taking in on average? They're not doing any of that stuff. Here's a bigger issue. They only measure the chemicals in the mom's blood and urine once during pregnancy. Once. Who knows what could happen? So now you're relying upon the fact that, okay, I got one measurement. I'm relying upon the fact that the lab did it right. I'm relying upon the fact that the lab didn't have issues. Oh, by the way, I didn't mention this. This is fun. They're missing about 1/3 of the data for the different chemicals. Lots of chemicals. I'm not talking just a few. I'm talking lots of chemicals. Let me pull up this table. I still can't believe this. Good Lord. So for maternal fish intake in pregnancy, they're missing about 1/3 of that data. So what they did was they created the data. We call it imputing. So they created the data to fill in those gaps. For gestational weight gain, they're missing about 12% of that data. Now, I said they're missing 1/3 of a lot of the chemicals. The metals, almost all the metals, they're missing 1/3 of the data. For DDT, they're missing 20% of the data. For the PCBs, they're missing anywhere from about 40% to 20% of the data. For different flame retardants, they're missing 50% of the data. Okay? For some of these other chemicals, it ranges anywhere from, 17 to 36% of the data. They have huge data gaps, and they are imputing the data. So they're putting false data, fake data in there so that the statistical algorithm can actually work. That's not any good way to actually build a model. So we've got a ton of missing data for everything. It's not like we're missing data for one thing and it's not very critical. We're missing data for most everything that they care about. They're missing data for a lot of these chemicals. They're missing data on different things about mom. They're missing all these different things. And then they aren't measuring the children's activity levels, how much food they're taking in, nothing like that. They're not taking in any of that other information whatsoever. Right? So that's not there either. And somehow, and it's only a single time point, right? They only measured the kids once. They only measured the moms once. Now think about this. They're looking at children ages from 6 to 11 years old. Okay. Some of these kids, as they're getting older, are probably entering puberty. And this is one of the things that the American Academy of Pediatrics points out, is the fact that this is hard. And it's hard because you can't, children are a very diverse life stage. A 6-year-old is not the same as an 11-year-old. And when you're talking about kids who are closer to the 11-year-old side, you're talking about kids who are entering puberty. So their metabolism is completely changing. And your metabolism isn't the same at 6 as it is at 7, as it is at 8, as it is at 9, as it is at 10, 11, so on. Your metabolism is constantly changing. So to even try to say anything about metabolic syndrome in children is just darn near biologically impossible. And so now you're trying to say things about 11-year-olds and 6-year-olds and saying that they're the same, but they aren't because of puberty and all these other things that are going on. So we just got all kinds of this just doesn't make any sense. It doesn't make any sense whatsoever. We can't generalize this information to the population. So, can we really say that, these chemicals are actually doing this? No, because we can't make the causal argument. And that's really what the problem is here. We can't make the causal argument. Yet, Yet CNN can technically get away with saying that these things are linked to these things, but it's based on a horrible study. It's based on a study that's missing tons of data. It's based on a study that doesn't take a lot of things into account. It's a horrible study. But because they use the word, well, it's only linked, no, that's nonsensical. And then they go on to continue to scare people about all of this. And it's just absolutely ridiculous. Absolutely ridiculous. So what do you need to take away from this? Okay, so wait. I got to finish one thing. Let's see here. Accept uncertainty. Good scientists are humble. Okay, so I don't know that these guys did anything wrong there. I think, CNN picked it up. I don't know how. They probably just saw it in the journal. Maybe there was a press release that went out. I haven't seen any press releases for this, so I'm not going to fault the authors for any of that. We need to check our biases. Okay, so I've tried to be very unbiased in my analysis of this, but I will say it is kind of hard for me because of my history of looking at all these studies. I generally come to studies very jaded. I like to think of it as skeptical, but it is technically a bias. So I need to, claw back some of that, still be skeptical, but, try to give them the benefit of the doubt. I'm definitely avoiding confirmation bias because I generally don't believe these things. So if you're someone who believes that all chemicals are horrible at all concentrations and you are scared by this CNN report, which, I think is reasonable to be scared by it, then you probably do need to check yourself for confirmation bias. And the best way of checking yourself for confirmation bias is to say, I'm going to be very skeptical when I look at this study. And I'm going to try to see the things here that stand out as not great. Okay, so we've gone through this study and we've identified the fact that, okay, so it is a small sample and it's a cohort study. Those two things right there should be the first things to tell you, I really can't trust this study. It probably is very weak. It definitely is not a U.S. population. And you start looking at all these other things, they're looking at 6-year-olds and 11-year-olds and treating them as same. That's not okay. They only measured it once. These are things that you can pick out that you don't need a PhD in toxicology or physiology or anything else in order to understand. These are things you can pick out of the study right away and just say, no, I think CNN is not doing anybody a service. They really shouldn't have written up this study. And that's kind of my bigger issue is science reporters. There are good science reporters and there are bad science reporters. And they really need to be thinking about what are the ramifications of what I'm talking about. Am I going to take some random study, which in this case I would call pseudoscience? Am I going to take this study and am I going to blow it up and make a big deal out of what they're saying? Or am I going to wait until the scientific community comes together and says, okay, so these are things you need to worry about and these aren't? The problem with waiting is you still got to write stuff, right? So if you're a science reporter for CNN, you got to write stuff. And if you're going to wait for scientists, then you ain't writing a lot of stuff, right? And that's kind of the catch-22 that they find themselves in. But I think we do need to either accept the fact that they're going to be writing about a lot of pseudoscience, or we need to accept the fact that, editors need to accept the fact that maybe their science writers need to wait and focus on other things when it comes to health and wellness and all that other stuff. And they need to wait for the actual science to catch up and to say, okay, so now that we've looked at this, let's look at this a little bit more holistically and look at a lot of studies and come to some kind of conclusion. That's kind of where I'm at right now. But anyway, like I said, this came out in CNN. It was Thursday, May 23rd at 4:38 p.m. And I'll have a link to the study. I'll have a link to the article at CNN. But yeah, it's very disappointing. Very disappointing. I worry about how many people are now going to get scared because of this story for absolutely no good reason. And that's really what irritates the crap out of me about all this stuff. Anyway, hopefully that was helpful. I think I like the idea of trying to walk through kind of my thought process as I'm reading some of these articles and discussing them with you. It certainly helps me get a better grasp of what actually did they do. Because if I'm going to come on here and talk to you, then I really need to know the study pretty well. And to help you, figure out things that aren't that you don't need a PhD for, that you can look at these studies and start assessing and saying, I don't know about that. Because there are a lot of things that you can pick out. You don't need a PhD to do this, right? I don't expect that you're going to know the physiology necessarily, but there are things that you can pick out and say, okay, so 1,301 mother-child pairs across 6 countries. That means 200 per country. It's not a lot of people. I probably can't really use this study to infer anything. Oh, by the way, it's a cohort study. It's not a causal study, so there is no control group, right? I haven't even gotten into all the stats. I'm not going to do a technical, breakdown of this study and discuss all the things that I found that I think are questionable or in some cases just flat out wrong. I'm not going to do that. But anyway, I think hopefully that was instructive. That's it. That's all I had to tell you. That's all I wanted to talk about today. Hopefully you didn't mind the one-way conversation. If you're screaming at your computer, or your podcast player, and you're like, oh my gosh, I have things that I want to tell him. You can find me in different places. Just track me down. And Twitter's probably the easiest place to find me nowadays. I guess I gotta call X now, don't I? Ugh, gosh. Yeah, that's right. It's now X. There I am at Datasci Burgoon. That's DATASCIBURGOON at Datasci Burgoon. On Twitter, you can hit me there if you have questions about the podcast, whatever. Anyway, it's always good talking to y'all. Make sure you like, share, subscribe, tell your friends, tell your dogs, tell your neighbors, tell their dogs, tell whoever you want to tell about the podcast. Thanks for helping me get the word out about the podcast. I really appreciate it. We're getting some increased numbers of listeners. That's always good. And again, if you have anything you want to yell at me about, hit me up at Twitter. All right. Thanks, everybody. Have a great day.